Hello guys, welcome back to STEM Trainers. In the previous videos, we saw stationary points, how to find or differentiate between local maxima and local minima points, and how to find them. So today we are going to see points of inflection. So now we are not going to go into much detail in this, but we are going to see uh, all the important points in this because it's a very detailed topic. Okay, so let's start. So first is, what is point of inflection? So point of inflection is a point where the concavity of the curve changes. Now that's the definition. Now what do we mean by concavity of the curve changes? So let's take an example. Let's take a graph of y equal to x cube. So you can see at origin, to the right of origin, the graph is concave upwards. The graph is concave upwards. And to the left of origin, my graph is concave downwards. Now you will be thinking, what is concave up? What is concave down? So now you can define this concave up, concave down in a lot of ways, but let me just give you a simple definition. So this is concave up. So what is concave up is, you can define it like this, that you can take any point on it and draw a tangent. You can take any point and draw a tangent. If the tangent lies below the curve, then it is known as concave up graph. Tangent lies below. Take any point, draw a tangent. If tangent lies below, then we say it's a concave up graph. Or there are other definitions also. You can say when f dash x is increasing. So if my f dash x is increasing, that is the gradient is increasing, then also we can say the graph is concave upwards. So we don't have to go into much detail. So these 2 points are more than enough. So what is a concave up graph? So where the tangent lies below the curve. And similarly, what is concave down graph? So concave down graph is a graph where tangent lies above the curve. Or you can say my gradient is decreasing. Okay. So now you understand what is concave up, concave down. So now you can see at origin, the left side is concave downwards, the right side is concave up. So you can say the concavity of the graph changes. So this point O is known as point of inflection. Where graph changes its concavity. Or you can say graph changes from concave to convex, or you can say convex to concave also. That's the same definition. Okay, now question comes. Okay, now we understand what is a point of inflection. Now question comes, how do we solve questions, or how do we find point of inflection if some curve is given? So let's try some questions and see how we can find it. So this is the question. Find the inflection points, if any, for the following curves. The first curve is fx equal to x cube minus 9x square plus 7x. Now, one thing that you can remember here is, very important note is, x equal to a will be a point of inflection, if f double dash a plus h and f double dash a minus h have opposite sides. What is this h? H is nothing but h is a very small positive quantity. I think we discussed this in first principle also. H is a very small positive quantity. Very, very small. Okay. So this is the definition that we can use, or this is important point that we can use to find the inflection point. So wherever the second gradient, second derivative changes its sign. So let's see. So this is the question. Now first thing we will do is we will find the second derivative of this. So let's find first derivative. First derivative is 3x square minus 18x plus 7. Let's find the second derivative. Second derivative will be 6x minus 18. So what you can do after finding second derivative is equate that value to be equal to 0. You will get some points. In this case, we are getting x as 3. Okay. Now, once you get f double dash x equal to 0 and you get a point. So this point could be an inflection point. So we have to check. So how will we check? We will see the sign of f double dash x. So at 3, I definitely know its value is 0. So that's how we find x equal to 3. Now what happens when x is greater than 3? Now you can just think about this. When x is greater than, let me just take 6 common so that it's easy to think. So this is my f double dash x. So when x is greater than 3, you can see f double dash x is positive. When x is less than 3, my f double dash x is negative. So I can simply say at 3, it changes its concavity. This is concave downwards, and after 3, it's concave upwards. So x equal to 3 becomes our point of inflection. Now let's find the coordinates. So when x is 3, what's the value of y? Y is nothing but f of x, right? So we have to find f of 3. So f of 3 means x equal to 3. So this will be 3 cube minus 9 times 3 square plus 7 times 3. Okay, so this will be equal to 27 minus 81 plus 21, which is nothing but 48 minus 81, which is going to give us 33. So y is nothing but 33 in this. Okay, and it will be negative 33. So my inflection point is 3 comma minus 33. So this is my point of inflection. So that is my answer. So now just remember, what you have to do is find f double dash x and then equate it to 0, find some x values and then check at which x values it is changing its sign. Okay, let's try one more question. My second question is x power 4 divided by 4 minus 4x cube plus 24x square. I have to find point of inflections if there are any. Okay, so first thing I will do is I will find f double dash x. So first find f dash x. What is the f dash x value? This 4 will cancel. This will be x cube minus 12x square plus this will be 48x. Then find f double dash x. So f double dash x will be 3x square minus 24x plus 48. And then equate f double dash x to 0 to find the potential points for inflection. Okay, so this 3 can be taken common. This is x square minus 8x and this will be 16. Let's try to make factors of this. 0 equals 3 into this is nothing but x minus 4, x minus 4. Okay, so from this we are getting x as 4, where f double dash x is 0. Now this x equal to 4 point could be an inflection point. So we have to see, what we have to see is f double dash x sign. So let's find the sign of f double dash x. We know at 3, this is 4. So we know at 4 it's 0. So what is happening when x is slightly greater than 4? When x is slightly greater than 4, let me just write this. F double dash x is 3 times. This is nothing but x minus 4 whole square. So even if x is slightly greater than 4, this will be positive. right? We can see this easily. Now, when x is less than 4, this value will be inside the bracket, we have a negative, but because it's a square, so it will again become positive. So now you can see in this case at 4, even f double dash is 0, but this is not a point of inflection because the concavity is not changing. This is concave up, this is again concave up. So there is no sign change. So we can say x equal to 4 will not give you a point of inflection. So the answer is there is no point of inflection. So for this curve, there is no point of inflection. So that's the answer. We have to find point of inflection if there is any. So there is no point of inflection. Okay, so just be careful in this. So you always have to check sign. You don't just do that f double dash x equal to 0, whatever x values you are getting. Okay, these are the points of inflection. No, don't do that. Okay, thanks a lot.